Now number 111 on the sheet really should have been just a C1V1 plus C2V2 equals W, and V1 and V2 would be column vectors with only 2 elements instead of column of length 2 rather than 3. Because, as you know, the pattern has been, let's do one in 2 dimensions, then we do one in 3. So number 101 was in 2 dimensions, number 2 was in 3 dimensions. Then number 3 was in 2 dimensions, number 4 was in 3. And I'm just doing the 3 dimensions. I'm not going to do the 2-dimensional situations. They're easier in that they require less calculation and you're less likely to screw up the numbers. And again, go back and check and see what numbers I might have screwed up, because I did this quickly in my head. I have no faith that I did it right, even though it's possible. Okay, number 111, you're given the equation C1V1 plus C2V2 plus C3V3 equals W. Okay, W vector. And the V1, V2, and V3 and W vectors are given to you. Now they're given to you as a row, like this one is given to you as 1 semicolon 17 semicolon 3. Well, what does a semicolon do? It tells you start a new row. So you write down 1 in your matrix. Then you start a new row and you write down 17. Then you start a new row, you write down 3. So you get a column matrix. And the same with V2, V3, and W. And I believe these are the vectors that you get. And now the equation looks like this. Okay, well, this equation then becomes a system. And I promised in class that I'd write out the details of how that happens. Don't have a lot of room here. So I think I can squeeze it in here. It'll have to be, okay, C1 multiplied by 1, 17.3 is just C1, 17C1, 3C1. And that's added to C2 times this column. Well, it's a scalar multiple of a column. The multiplication distributes through the column. So that's going to be what? C2, 26C2, 5C2, plus what? Yeah, things are going to get a little cramped here. But this come out in good resolution. If you do this in full screen, you should be able to see this, and you should understand it just from what I'm saying anyway. C3 multiplied by these is going to give me negative C3. That subscript 3 might be a little hard to write. I'll try to do my best. But that's going to be hard to read. But that's negative 35C3. And then negative 7C3. And that 3 is totally illegible. Chalk is just too wide. But, just going to have a C3 with each of these. And that's going to equal negative 1, 37, 8. Okay, well, what's that? If we add these up, if you add 2 matrices, you just add them component by component or element by element. So we're going to have C1 plus C2 minus C3 equals, C1 plus C2 minus C3, going to be the first element here. And then add the second. We're going to have 17C1 plus 26C2 minus 35C3. And then 3C1 plus 5C2 minus 7C3. Okay, and that's going to equal the column negative 1, 37, 8. Now, this just becomes the product of 1, 1, negative 1, with C1, C2, C3 equals negative 1, 37, 8. I'm not done. Okay, if I have 1, 1, negative 1 here, what's that give me? 1, 1, negative 1 times the column C1, C2, C3 gives me 1 times C1 plus 1 times C2 minus 1 times C3. In other words, just C1 plus C2 minus C3, which is what I had here. Okay, and the other numbers are easily understood. 17 here, 26 here, negative 35 here gives me 17C1 plus 26C2 minus 35C3. And then my last row, for reasons that I think you'll understand if you understood what I just said, multiply this last row by this column, I get this expression. And, of course, all I've done is I've taken this expression and expressed it as a matrix times my C1, C2, C3 column vector, and set that equal to the column vector that I've had on the right-hand side ever since the first step. So that this is now of the form A matrix times a C vector equals the W vector, which of course I wrote out right here. But I didn't write out these steps, and it's very plausible that you need those steps. Okay? So now, how do I solve this matrix equation? Well, you know, since we're doing review here, that you can multiply the inverse matrix on both sides, the inverse of the A matrix, and get your solution, but we're not going to do that. We're going to do it by row reduction. Okay? It should be clear from this form here that C1 plus C2 minus C3 equals negative 1. That's this equation. That 17C1 plus C2 minus 35 C3 equals 37. That's this equation. And that the third number, the third quantity, the quantity in the third column of this column matrix is equal to the quantity in the third column of this one, so that you get this third equation. Okay, so we translate this condition into this, and then it's straightforward, but you might need to write out the steps, and I recommend that you do to reinforce what's going on so you don't lose track. And having written down the steps, at least down to here, you get this system of equations that gives you this augmented matrix. And of course, this augmented matrix corresponds to this matrix equation, where the A matrix, well, there it is. Okay? Okay, so for the given V1, V2, V3, and W, this equation gives you this matrix, with the interpretation that our first variable C1, so these represent coefficients of C1, coefficients of C2, coefficients of C3, and the right-hand sides. Okay, now we're going to go ahead and see what happens. Well, actually, yeah, we'll just finish this up. Okay, so I didn't actually do the reduction of this matrix. I assume you can do that. So this matrix might give you this, okay? But it might give you something worse. And actually, I am going to amplify that a little bit, so I'll talk about this in the next video.